So,
hi, we're here with Sid Ball and Dick Engel, who are both former participants on the Molten Salt Reactor program. And maybe you gentlemen could just take a minute and tell us what you did on the program. Sid?
Well, yeah, I started out at the lab in 1957, and shortly after I got started at the lab, I got onto the Molten Salt Reactor project, the MSRE, Molten Salt Reactor Experiment Project, mainly in the instrumentation and controls aspects of it. But I quickly got into the dynamic analysis, which was a lot of fun for that reactor because it's an inherently safe reactor. The dynamics were, let's say, not common to reactors because it was molten salt instead of water-cooled solid fuel reactors. So it was a challenge, and it was also a whole lot of fun because it wasn't just working on reactors that somebody else was building off somewhere. It was one that was built right here in Oak Ridge, and so I got to work on something that was tangible and something I could get my hands on. And besides the dynamic analysis, I also did the training simulator for the molten salt reactor, and I think it's probably the cheapest reactor training simulator ever devised by in the nuclear industry, because what I did, I set up simulations of the molten salt dynamics on two little portable analog computers and wired them into the actual control panels of the molten salt reactor, and the operators could fool with the controls and instrumentations on the panel and pretend that it was really the molten salt reactor operating. And this was done, of course, before the reactor started operating. So it worked out pretty well, I think.
Excellent, excellent.
Well, I go back.
Introduce your name, please.
Oh, all right, I'm Dick Engel. I go back maybe a little farther than Sid on that program. I migrated to the MSR program from the aqueous homogeneous program, which closed out about 1960. But we did spend some time finishing off documents related to that program, and then got into the MSR, which the MSRE was already underway as a follow-on to the aircraft nuclear propulsion program, which had been closed out about 1959. I was involved initially in some of the core nuclear analysis. The core design was already complete at that time, and then moved over not long after that to the reactor site, which was still under construction. Became involved in the operator training, the preparation of operating procedures, things related to that, and the experimental program. And then as the reactor came into operation, I had a group of, just a small group of people who were doing the nuclear and mechanical analysis of the performance of the reactor. We had input into the program, the experimental program, as well as the analysis of the results of that program, and followed it all the way through to the shutdown of the MSRE, and then subsequently looked into the design of conceptual systems that might have been implemented had the program continued. And that continued up into the late 1970s with some of the incidental studies that were carried out. And after that, I drifted off into other areas of
High achievement.
work at the laboratory. Ended up as a technical assistant to the deputy director of the laboratory before I retired.
Excellent. What year did you retire, Dick?
1991.
1991. How many years did you serve at Oak Ridge at that point?
37.
37 years,
plus
fantastic.
37 and a half.
Now, Sid, could I ask you a question? A lot of people don't know very much about how nuclear reactors work and the notion of dynamics and so forth. They don't understand it. And often folks are afraid that a reactor can run away on them, that a reactor is somehow an inherently unstable system that people have to always be keeping their eye on lest it get away. A variation on this is some people think that we shouldn't even run reactors critical. If we ran them subcritical, that would somehow be safer. And I was wondering, Sid, if you could talk just a little bit about what makes a reactor like an MSR inherently safe and stable.
Well, okay. Nuclear processes are pretty well understood. There are certain designs you can make of power reactors that will, let's say, be self-controlling. In other words, if the power tends to go up and the temperatures go up, it automatically corrects and shuts itself down, or at least doesn't let it keep going up. And it all depends on the design of the reactor. The molten salt reactor.
In a critical reactor, then?
Oh yeah, sure.
Okay, so
yeah,
if it's
the
critical.
Idea, well, I don't know if you want to print this, but the idea of having a subcritical reactor and then an accelerator to provide the thing to go beyond that, I think that's crazy. I mean,
and do you think it's crazy because the reactor doesn't need that because it is inherently self-controlled?
oh well, the designs that are inherently self-controlling, like the molten salt reactor and the high temperature gas cooled reactor, they take care of themselves. Other types of reactors, you know, there may be a problem with it running away, but it's just a matter of designing it so that it doesn't.
And is it very hard to design a molten salt reactor to be self-controlling?
I think the nature of the molten salt reactor, the one with the fuel mixed in with the salt, is basically inherently safe and, you know, self-controlling.
Depending on the particular configuration, you can go to some exotic configurations that have a lower coefficient, let's call it a stability coefficient, than some others. But by and large, just about any molten salt concept that has been seriously considered has been shown to be to have this stable behavior. That's not to say one couldn't come up with one that is.
That's kind of always the
If you worked hard, you could probably make it screw up.
The point is, would you say you would have to work hard to make an unsafe version?
I would guess so. I mean, just the basic characteristic is that if you have the molten salt in the core region and it heats up, it gets less dense, and that means it's less likely to go more critical. In other words, it gets less critical as the density.
Or less reactive.
Yeah, less reactive.
Yeah.
And this isn't theoretical for you. You actually operated the molten salt reactor experiment and verified these behaviors, correct?
Yeah, well, I wasn't an operator, but I did run experiments on it, and showed what everybody else had already showed, and we had all proved that it has characteristics that make it inherently safe.
Was it kind of satisfying to see the reactor respond the way you thought it would respond according to your models?
Well, of course. Yeah, it doesn't always happen that way in predictions. I spent a good bit of my career there simulating things, and I think the molten salt reactor was such that I nailed it better than most of my other projects.
Excellent. So if we were to go forward in the future and build a new molten salt reactor, would you feel safe in saying that if it was designed well, that it should be a critical reactor versus a subcritical reactor?
Yeah. Oh yeah,
Okay.
yeah. I think the idea of subcritical reactor is sort of foolish, because it depends on, mainly it depends on an accelerator operating like you want it to. And I'm not an accelerator person, but I understand their downtimes are significant. So why have that albatross hooked onto your reactor that otherwise would go
the
fine?
reactor availability, reliability is substantially better than that of the typical accelerator system.
Yeah.
Well, Dick, I have a question for you. You worked on a number of designs for other versions of molten salt reactors in the 70s. And would it be safe to say that you were part of some of the last designs that were going forward on this?
The last ones that were going on at ORNL. Now, what was going on other places? Well, we know, for example, that the Japanese were working on designs that they had. I know very little about the more advanced designs. They had visualized a program that would start with a reactor about the size of the MSRE and then progress up through stages.
That was Furukawa's work.
That was Furukawa's work.
But the design that you worked on, the DMSR in the late 1970s, was that motivated by the Carter administration's proliferation position?
It was. There was a program instituted that was designated the Non-Proliferating Alternative Systems Assessment Program, NASAP. And they looked at reactor concepts that were developed by people around the country. I think they ended up with something like half a dozen concepts, one of which was a molten salt concept. And we looked at a couple of angles or a couple of variations on what that might be that would involve lower enrichment fuel, less than 20% fissile, that would have other characteristics that would make the reactor less susceptible to diversion of material, and came up with a system that we thought looked very promising from the performance standpoint. One of the systems was one that we felt could be operated for 30 years without having to refuel. Well, I shouldn't say refuel because it required continual addition of fuel, but continually adding fuel in a liquid fuel system is very easy. So that it was a system that could be expected to operate for 30 full power years equivalent without having to change out the main fuel batch. And that looked promising to us from a number of angles, including not only diversion and proliferation resistance, but also waste and and ease of maintenance and disposal of the materials at the end of life.
Now, was that intended for deployment in other countries outside of the United States? Because the United States obviously already has nuclear weapons and probably would never choose to divert an existing civilian reactor to weapons production.
We did not make any effort to identify siting for the reactors. This was aimed at developing a reactor concept that would have certain characteristics, including proliferation resistance, without really looking at where such a system might be sited.
Was the Carter administration's position on proliferation a major motivation for that design?
Well, the program was instigated through, and I guess at that time it must have been DOE. I've forgotten when we changed from AEC to ERDA to DOE. But they requested the work. And so what we were doing was responding to their requests of concepts that might meet certain design specifications that they provided.
Mm-hmm.
we were responding to their request rather than coming up with something and proposing to them.
Did either of you gentlemen meet Alvin Weinberg?
Oh yeah.
Sid, for you, did you ever spend much time talking with Weinberg about where he thought the molten salt reactor program was going with thorium?
No, I didn't.
Did you have any opportunity to speak with Weinberg about his visions?
Not
for
really.
thorium?
I had very little, well, I had a little bit of social contact with Alvin at non-nuclear functions, but never got into any real discussions about nuclear philosophy as such. It just never came up.
Okay. I assume both of you might have read his book, and it's clear from there he did have a lot of nuclear philosophies in that book about how nuclear power could be used for desalinization and perhaps to increase the peace and security of the world.
Oh yeah, he was the main reason I came to work here.
So you knew of him before you came to Oak Ridge? Okay. How did you learn of Alvin Weinberg?
When I was looking for work, I just and was interviewed by somebody from Oak Ridge. I read up on Alvin Weinberg and said that would really be a good place to work. So.
Were either of you present when the molten salt reactor program was canceled in the early 70s?
Yeah, we were still working
there.
there.
I was still working on the system. We were still finalizing reports on the performance of the MSRE and looking at future concepts of the next reactor was the, what did they call that?
MSBR?
MSBE?
No, MSBE. There was a follow-on reactor.
Demonstration reactor.
Yeah, and I've forgotten what the name of it was at the moment.
Several different flavors of it.
Yeah, there were quite a number of different.
In the neighborhood of 60 to 100 megawatt system, where the MSRE was 8 megawatts, although I was not directly involved in any of that work, I knew that it was ongoing, as well as work on the large 1 gigawatt breeder systems. And at that time, the emphasis in the early 70s was still on breeders. And of course, that was one of the reasons, I think, that the emphasis turned away from the molten salt system to the liquid metal cooled fast breeder system, because of the higher breeding performance of those systems, and the notion at that time that breeding would be essential if nuclear power were to succeed. I think people have since recognized that high gain breeding is less important now, and probably has always been less important than it was perceived to be at some times during the earlier years of the program.
And the liquid metal fast breeder reactor was by and large sold on the promise of high gain breeding, is that correct?
That's my understanding.
Sid, how did you feel when it was announced that the program was canceled? Did it come as a surprise, or was it something that you saw coming?
I didn't see it coming. And yes, it was a surprise, but I was not privy to the politics at the time. I didn't understand, the interplay between the fast breeder people and Alvin Weinberg's mission with the molten salt reactor. I was more involved with studying the dynamics and seeing where we could go from there with the different fuels. We did our dynamics testing and predictions on both the U-235 fuel and the U-233 fuel, and I was absorbed in that and away from the political nature. Well, there's one big difference in the way projects are done back then versus now. I think there were maybe 2 or 3 guys from the Molten Salt project that would go to Washington and do the dealings up there, and the rest of us would be back home working. Now, when we have a reactor project, just about everybody on the project spends time dealing with the bureaucracies, and therefore less time and money available for the real work on the project. And that's a sad state of affairs,
I
I
agree.
think.
According to Weinberg's biography, he was let go at the end of 1972, and the program was canceled on January 1st, 1973. So how did you feel when the announcement came right at the beginning of the new year that the program had been canceled?
Well, I was, of course, disappointed, but I didn't, like I say, I didn't understand the reasoning for it. I didn't even know if he had retired voluntarily or whether he was pushed out.
Do you feel like the program had a sound technical basis, or do you feel like technical problems were the basis for cancellation?
Some of the technical reasoning that I heard for the cancellation was that there was a corrosion problem, and that part of it was not my field in the molten salt reactor, so I didn't really understand that.
Okay, well, I'll ask just basically the same question to you.
Well,
too.
yeah, there were actually there were 2 or 3 issues brought up. Corrosion, or let's say the materials problem with the structural material, was one. Tritium was raised as another issue. We made no effort on MSRE to do anything with tritium, and there was a perception that managing tritium was going to be a very difficult, if not insurmountable, issue by some of the people apparently who were the decision makers.
And these were not people on the MSRP, but rather people who were the decision makers in Washington?
Yeah, well, let's face it, at my level, I didn't know who the decision makers were, let alone what their reasons were. The things that I am mentioning here are things that were published subsequently.
This is the WASH 1222 report from the AEC. Did the people on the program feel like tritium was an insurmountable problem?
Not really. We recognized that tritium would have to be captured and sequestered for the system to be viable. But most people thought that that's something that we should be able to do without.
Did the people on the program, particularly the chemists or the material scientists, feel that corrosion was an insurmountable problem on the program?
No. I think the people that I dealt with or that I spoke with felt that, okay, this is an issue, specifically the tellurium issue, but we can get around that. And in some of the subsequent work, subsequent to that initial shutdown, they did some experimental work that seemed to bode very favorably for an ability to solve that issue. As well as the tritium issue, by the way, because we did do some tritium experiments in that 1974 to 76 period, and those are documented.
So would it be safe to say that the technical personnel on the molten salt reactor program questioned whether or not there was a technical argument against shutting the program down?
Well, I don't think any of us felt that we were in position to question the decisions that were made. That was not our role.
Did you wonder if the people who were making the decisions were in possession of all of the technical information needed to arrive at a proper decision?
Well, you always have that sort of thing going through your mind, but I couldn't couldn't say, you know, that, gee, this guy doesn't know what he's talking about with respect to this subject, or this guy doesn't know, because A, I didn't know who those guys were, and second, I didn't know which of the aspects they were talking about. That was at a level well beyond where I was.
Well, there's been many years since this decision was made, and the liquid metal fast breeder program, of course, went on to cancellation itself. It did not realize the breeding gain, even in concept. Looking back now, do you feel like the decision made to shut down the program was appropriate, or do you feel like it was a mistake?
Well, I think the program still has potential, whether, and to a degree this depends on what were the resources available, what was the position of the government with respect to all of the things in which the government is involved.
Many hundreds of millions of dollars were expended on the LMFBR after the cancellation of the molten salt. So I don't think it was a resource limitation that prevented the government from pursuing it. And we have documentation on that, and the expenditures year by year up and through the mid-'80s. So
well, there's a question of what is an appropriate use of resources. If you have an effort that everyone thinks, gee, this is something that we really need to work on, and everyone is in agreement, and over here is another project which is much less interesting, appears to have much less potential, at least in quotes, our perception, whoever our is.
And our perception was based on high gain breeding?
I think to a large extent it was.
And obviously, with thorium fuel and a thermal spectrum, you can't realize high gain breeding. It's simply in the physics. You can realize breeding, but not.
But just barely.
Yes.
Really, if you get right down to it.
So it's clear that if that is your metric, then the right decision was made. The molten salt reactor couldn't do high gain breeding, but maybe that wasn't the right metric. Sid, your thoughts on the cancellation?
Well, of course, having worked on it, it was, to me, a very friendly design in terms of safety and potential. I was never a big fan of the liquid metal fast breeder because of the, let's say, the lack of inherent safety characteristics on it. And I, being more, well, mostly into the dynamics area myself, I felt that that was an extremely important aspect of it.
Did you ever study the dynamics of the liquid metal fast breeder reactor?
Enough to know that it had some, let's say, potential failings. Yeah, right.
Well, gentlemen, it's been a great pleasure being with you tonight. If there's one question I could just wrap up with, do you think building molten salt reactors in the future would be a good idea?
Oh, heavens, yes.
Dick, what do you think?
I think it would be a very good idea, but it's an idea that would be a long time coming. What we have to base our judgments on is one experiment, which as a first of its kind experiment was very highly successful. But it also left a lot of questions unanswered. And if you're going to have a successful commercial application, all of those questions have to be answered. And they can't be answered in a few months' time, or even probably a few years' time.
Do you think we need a prototype to answer these questions?
A prototype could go a long way toward answering some of the questions. The questions that relate to what's the 30-year life expectancy for this alloy can't be answered.
Those can only be answered in actual operational experience, just as they were answered by the actual operational experience history of the light water reactor.
Absolutely.
What's your thoughts on this pertaining to just energy in general and the world you live in? Like, you know, you guys went through the oil embargo and stuff like this. Why do you think, if you could just speak to the general population, why do you think efficient reactors are important? Like, reactors that generate less waste and are safer, like, you know, kind of paint a broader picture.
Should we be
here,
even
like,
looking at nuclear for energy, you know?
Let me say this about that. Anybody that's ever seen that curve of our use, the humans' use of fossil fuels, has seen it just take off exponentially. Now, the fossil fuels we're talking about are not infinite in abundance. Pretty soon, it's going to be a big problem just for the resources of fossil fuels. And I think our generation has been amiss in not addressing this problem of paying attention to what our grandchildren and great-grandchildren are going to be up against when we run out of fossil fuels. And the idea of not spending an awful lot of resources that our country especially is not spending is really bad, very bad. Also, the people at the lab and other places around the country that study the global warming situation say that it is a serious problem down the road. How far down the road, I don't expect to see myself because I'm an old codger, but I think my grandchildren are going to see a heck of a big problem from global warming. And of course, as you know, the power reactors don't contribute CO2 to the atmosphere. And so they should, by golly, be pursued, period. And not to do it is sort of insane, really.
Completely
We hear so many people commenting, especially on commercials on TV, we have enough natural gas to keep us going for 100 years. 100 years is a very short period of time. And if we're going to run out of our natural gas resources, our domestic resources, in 100 years, we, by golly, ought to be looking for something to take over when those are gone.
It's hard after you've been exposed to the potential of thorium to be satisfied with 100 years anymore, isn't it?
That's right. 100 years is a very short time. And if you look at the oil consumption, and even if you say that we can still go up into the polar regions and drill under very difficult conditions without disastrous after effects or side effects, and bring that out, we still have a finite source of fossil fuel materials. Even if you take in the methane hydrates, which nobody has figured out how to tap yet.
Safely, because that might flip.
If
that flips, global warming is going to be a wee big problem.
Well, I've asked questions, and before we wrap up, if there's anything you want to say, please feel free to. This is going to be, probably a lot of people are going to see this, so if there's anything I didn't ask you that you want to talk about.
Well, you know, I think the thorium resources are known to be very plentiful, especially in India and Brazil. And I think it certainly makes a lot of sense that India is going that way, looking at use of thorium as a fertile material. And I think we should also be looking at that, especially since it can be used by reactors such as the molten salt reactor and the high temperature gas cooled reactor.
Yeah, I think I think it would be tragic if we don't follow this and end up buying another technology from foreign powers in other parts of the world without identifying any particular foreign power.
Well, just in case it's China. China currently makes my squash rackets, and pretty soon they're going to be making my reactors if we don't turn this around a little bit.
Well, unlike most people, gentlemen, you two did something about it a long time ago. And thank you very much. I greatly appreciate all your work. Thank you. And thank you for your
having
time,
us,
too.
and thanks for dinner.
Exact same thoughts for me. Thanks for all your work.
Thank you.
You're very welcome.